Hi guys, it's Miss Leslie. I'm coming to you with the video about rational and irrational numbers. I was hoping that the PowerPoint that I sent out would be enough, but a couple of us have a couple of questions, so I want to make sure that we understand the difference between the two. Guys, the quick and dirty, just like it said in the PowerPoint that I sent you, is that rational numbers are numbers that can be turned into a fraction. So guys, anything like a percent, a perfect square, a fraction, a mixed number, anything like that, any number is rational. But all irrational numbers are numbers that cannot be turned into a fraction. So guys, if you know what irrational numbers are, it's very easy to spot what a rational number is. So on the back of my paper, I've got a little chart. One for irrational and one for rational. If you can remember that these three things are irrational, you'll have no problem spotting rational numbers. Okay. First irrational number, guys, you need to make sure that you keep in mind is pi. And I know that you're very familiar with pi, having found volume, the square year of cylinders and spheres and cones. So guys, anything that has any dealings with pi is irrational. For example, if you have pi that is being added to something, or pi by itself, or pi being multiplied by something, all of those numbers are irrational. Okay? Second category that we need to make sure that we recognize for irrational numbers are imperfect squares. For example, square root of 12. Square root of 12 is irrational because there's no number that you can multiply times itself that will give you the 12 that's on the inside. Now I know you can say, well, Miss Leslie, 3 times 4 will give you 12, but 3 and 4 are two different numbers. I said a number that can be multiplied times itself that will give you the number that's on the inside. Okay, when you find the square root of 12, you'll get this long decimal, 3.464101, and it goes on and on and on. And because it goes on and on and on, I can't find a decimal place to know how many zeros I can put in the denominator to make it rational. Okay, so that's why any number that is not a perfect square is irrational. The last category that we need to make sure that we keep in mind that makes a number irrational is a non-terminating, non-repeating decimal. For example, if I have the decimal 0.14972618674 ... that is also an irrational number because the number goes on and on and on and on and on, and it doesn't stop and it doesn't repeat. This is called a non-terminating decimal, which means it goes on and on and on and on, and it doesn't repeat itself. So guys, any number that has any dealings with pi, any number that is not a perfect square, and any number that is not a non-terminating, non-repeating decimal are irrational. Now let's look at some examples of some rational numbers. So if non-perfect squares are irrational, then that means perfect squares are rational. All your square roots, like square root of 4, which is 2. And you might say, well, that's not a fraction, but you can take 2 and turn it into a fraction by putting it over 1, right? Or square root of 16. Square root of 16 is 4. How do you turn 4 into a fraction? By putting it over 1. Or square root of 225, which is 15. Same thing. I can turn it into a fraction by putting it over 1. So all perfect squares are rational. All fractions are rational. 3/4, 6/9, 1/5. They're all rational. All repeating decimals are also rational. So guys, if you have a decimal like 0.2 with a little line over it, that's called the bar notation. That means that the decimal goes on and on and on and on and on. It's 0.2222222 ... But this is a rational number. I saw in one of the pretest questions, they were asking you, how would you take this rational number and turn it into a fraction? Well, what you would do is just find a place where you would want the decimal to stop. I'm going to stop it right here in the hundredths place, I'm going to count tenths, hundredths, so I'll know it to be written as 22 over 100, and then you simplify it if needed. 11 over 50. Okay, so all repeating decimals are rational, and all terminating decimals are also rational. If you have a decimal like 0.13, see, the decimal stops. That's what terminating means. It stops by itself. So I know exactly how to write this as a fraction. This decimal stops in the hundredths place, so it will be 13 over 100. This decimal stops in the tenths place, so it will be 2 over 10, or 1/5. So all terminating decimals are rational. All percents are rational. 46% is a rational number because I can turn it into a decimal and then turn it into a fraction. 46% as a decimal will be 0.46. And this is 4/10, 600, so it'll be 46 over 100. We know that's rational because we can turn it into a fraction. And guys, don't forget, like I said, all terminating decimals. So guys, as long as you can remember what irrational numbers are, everything else is rational. Okay, anything that deals with pi, any non-perfect squares, and any non-terminating, non-repeating decimals are irrational. But everything else over in this category is rational. If you guys have any questions, make sure that you're texting, emailing, calling, or sending me a message through Odysseyware. Thanks, guys.